Alright, welcome to our 10th video of Unit 7. This one we're talking briefly about the structure of the periodic table. Now, to be honest, you may actually already know all this, even though I've never taught you this. You've probably seen this pattern, but I am basically taking time to officially show you that there is a pattern to the periodic table, which again, you probably knew. So, the locations of the elements on the periodic table correspond to their electron configurations. Now, it originally was started by a guy named Mendeleev, and he kind of estimated that elements were organized closely by something. He sorted them by chemical properties. You've seen recently, and you're going to see later, that their chemical properties mainly deal with their valence electrons, and we've kind of revised it since then, and now our table is mainly sorted by electron configurations. So, elements in the same column of the table have similar valence electron configurations. Now, that does not mean they have the same. Most of the time, they're pretty much the same number of valence electrons. Transition metals change a little bit. Some of the ones under, like, transition metals change. Few of the F elements change. But most of them have the same number of valence electrons. For example, all 2A elements, which are alkaline earth metals, have an NS2 configuration. N meaning whatever energy level they're in. So if they're in the third energy level, they're going to be 3s2 or 4s2. I'm sorry, I said that wrong. N refers to their energy level. So all the 2A elements have S2, but since they're on different rows of the periodic table, it's representing that their valence electrons are in different shells. So one may have 1s2 or 2s2 or 3s2, but they're all s2. And all 3A elements, which are boron, aluminum, etc., are NS2, NP1. So, for example, 1s2 or 2s2, 2p1, or 4s2, 4p1. Yes, there may be D elements or F elements or F electrons in D blocks or F blocks in between them, but valence electrons are S and Ps. So their valence electrons, basically their outer shell, will all have something S2 and something P1. And again, N increases as we move down a column. The number of columns in each block correspond to the maximum number of electrons that can occupy each kind of subshell. So the S block, there are 2 columns in the S block. Kind of as a reminder, those first 2 are S. Okay, our second big chunk is P, and P has 6 columns. The middle D each have 10 columns. And F has 14. And that refers to the fact that we have, one S orbital with 2 electrons. So we're going to find, well, you don't really need me to explain that, you get it. Okay? And as a reminder, 2, 6, 10, and 14 are the number of electrons that can, I just said that, why am I repeating this? Well, here you go. Again, 2, 6, 10, and 14 are the number of electrons that can fill the S, P, D, and F subshells, respectively. I literally just said this. Thus, the S block has 2 columns, the P has 6, the D has 10, and the F has 14. Sorry. But, well, hopefully you won't remember it, or won't forget it. Finally, recall also that the 1S is the first S subshell, 2P is the first P subshell, 3D is the first D subshell, and again, that's in row 4, and 4F is the first F subshell, but it's in row 6. So, basically, what your configuration comes down to when you look at the table is you basically figure out what row it's in and what block it's in. Now, if that is, so what row it's in, we're going to call in. At least, we're going to call that in for right now. Okay. S orbitals, electrons in the S block are going to be in S something. And then that something is basically whatever column they're in. So if they're in the second column of the S block, it's S2. If they're in the first column, it's S1. Okay, P orbitals are going to be in P. D are going to be in -1. And F are in -2. So if you find something in the 6th row, okay, then that would say we're going to use 6 to represent our in. That would say if it's in the S block, it'll be 6S. In the P block, it would be 6P. In the D block, it would be 5D. And in the F block, if you found that it came from the 6th row, would be 4F. And then again, the number, it's just count how many columns there are, for the most part, what column it is within that block. Is it in the 5th column? Is it in the 6th column? Is it in the 10th column of the D block? And then that just becomes your exponent. Now, that's not always true, as we're about to learn in the second video, but it gets you pretty close. Thanks for watching.